So as you guys know, I'm sure you're familiar with a linear equation in one variable, which is going to fit this format. And please go ahead and start taking notes if you haven't already. Nothing strange about this linear equation in one variable to be written in this form. So what if we jump in, just go ahead and jump ahead into, we're looking at solving a linear equation involving fractions. So basically the gist of the lesson. If we have time, we'll get into rational equations. So, and again, I plan on having all of these videos hopefully uploaded before the end of next week. And then it'll just be a routine thing where all these videos are uploaded on a regular basis. All right, ax plus b equals 0, linear equation, and single variable. I do encourage you, even if you think, oh, let's watch the videos again, let me emphasize, writing something down does help with memory. I think you guys probably may already know that, maybe don't realize that, but still write it down in your book, because that's kind of like take advantage of studying while you're in the class. I don't want you guys to just rely on these videos. Okay, so next one, looking at an example, we have something looks like this. Any questions? Okay, so x plus 2 over 4 minus x minus 1 over 3 is equal to 2. So this is still considered linear equation in one variable. We just have fractional coefficients. And this could be written as 1/4 x plus 1/2 minus 1/3 x plus 1/3 is equal to 2. Right? We could do that if we wanted to. We could write it like that, and so you definitely see that it's technically going to be a linear equation. Go back to here. Ax plus b equals 0. Yes, should technically be over here, where a and b are, and I'm just going to use this. You guys know that way out of the real. Right, okay.
What?
Now, this is just real numbers. This means symbol for real numbers. Anytime I give you something that's like, yeah, I've never seen that, let me know. So this just means real numbers. All right, so this is the definition of a linear equation, single variable. So if you look at this technically, you could write it like that, where you'd have something x plus some constant equals 0, just by manipulating this around. This is definitely a linear equation. It may not look like it initially, but I want you to understand that it definitely is. Yes.
We're gonna go through and try to solve a linear equation, right? Like we're gonna.
Yep. We're gonna solve x. Yep.
All right.
All right. What's wrong?
Memory.
Oh yeah. I'm gonna teach you guys. Yes. What's that? What's the what? Here? Okay, yeah, so this here, all I'm demonstrating is like, remember, you can divide each component by the denominator. So x over 4, another way of writing x over 4 is just 1/4 x. Plus 2 over 4, which simplifies to 1/2. Now minus, if I skip ahead, let me know if we're going to. If I skip some steps you want to see, please let me know. Minus x over 3, which is another way of saying minus 1/3 x, right? Minus a negative 1/3, which becomes a positive 1/3, right? This is not the way I'm going to solve it. I just wanted you guys to see this And then if we simplify this to get the form ax plus b equals 0, you would clearly see that it's definitely, it fits a linear equation.
Okay.
Okay, that's all. I'm erasing this line. This is not the way I solve this. I like the easy way, okay? This is not the easy way. I'm just demonstrating this is a linear equation. I want you guys to feel comfortable. When you see it, oh, that's a linear equation. It's not a rational equation, even though I probably still call it that. But it's usually we refer to rational equation when you have variables also in the denominator. That's when we talk about rational. Yes. That's our hand up. No? Okay. So I just want to demonstrate that. So now I'm going to go ahead and I'm just going to erase this. It's a much bigger eraser. Okay. Here all day. Okay, so how would you, anyone know how to solve this? Would like to come up here and solve this? No? Okay. I'm all about that if anyone wants to knows how to do it. Okay, so here, do we cross multiply is being asked. And the way it is, you cannot cross multiply because it's not just, for example, just this. In which case, okay, I have a rational value equal to another rational value. We have this big difference here, so we cannot just cross multiply. Yeah. I am going to multiply both sides by some value. And which value do you think?
2.
Okay. Okay. You could multiply something by 4, but I would still be left with an issue with the fraction here. So we're getting there. There's a bigger number I can multiply the entire equation by, meaning both sides of the equation, that would completely get rid of these fractions. Yes? Well, the problem 2 would not be large enough because I would end up still having like 2 over 4.
So would it be 12?
Yeah.
It would be 12. Yeah. It would be 12.
Yeah.
And 12 would be the least common denominator. So let's go ahead and do that. Now here's the thing too. Don't worry about it if it's not the least common. If you find any common denominator, that's going to work. It's preferable to use the smallest because then you just don't have to worry about larger numbers popping up. So let's go ahead, multiply both sides by 12. I'll multiply this side by 12 and multiply this side by 12. Okay, if you want, if it makes it easier to see, you can always write a number over 1. Right? Because now you see, oh, okay, so the 12 and the 4, we can always, when we multiply fractions, we can always simplify diagonally or directly up and down. So you look at the 12 and the 4, what would happen there? Well, you have 12 over 4 is just 3. So now you have 3 times x plus 2. No? I'm just distributing this 12, I'm distributing to this guy. Remember the distributive property of multiplication over addition? It's like, okay, if I have a guy on front, I'm going to distribute him to each part. So first this one here. 12, I could literally write 12 parentheses x plus 2 all over 4. But what is 12 over 4? 3. Right?
Oh, I did it wrong.
What's the long way?
I don't know, I just get it.
Okay. The reason we're doing this is to get rid of fractions immediately, yes.
Okay, I'm confused. Okay, so the 12 you're multiplying by the x plus 2, right?
Yeah, I'm multiplying this whole guy by 12. Actually, we're going to be doing this. We're going to be saying, okay, actually, just a different color. We're going to say, okay, to here and to this guy. So view these as two, like this is a term and this is another term.
Okay. Alright.
So 12 and 4. I mean, if you want to see like this specific one, you could do this. You could say, okay, 12 and 4 both have 4 in common. So the 4 would become, 4 divided by 4 is 1, 12 divided by 4 is 3. So that's why this is 3 times x plus 2. I'm just not showing that. Because at this point, you guys are 12 over 4 is 3. So let's show that. So now, then we have to distribute the 12 to this term. Okay, well, again, we can always, when we multiply fractions, we can always simplify diagonally. So I'm going to, 12 and 3, the whole reason why we take 12, because now we'll get rid of that 3, so to speak. We'll make it go away to 1. Well, what's 12 divided by 3? 4. So we have minus 4 over x minus 1. I want you guys to realize I could do this, but the whole reason is this, so we don't have to do it. So there's no longer fractions involved, and it's kind of redundant to say over 1. And so this equals 12 times 2, which is of course 24.
And we go ahead and distribute.
Yep. Yep. You guys want to see the rest of this? 3 times x plus, this is just a distributive property. Boom, boom, plus 3 times 2. Now, minus 4x. Now, this is where you need to be careful. In fact, you can be very safe and do that. I'm going to encourage you guys to play it safe. You can always change addition to subtraction to addition. That way you know that that negative sign is associated with that 4. It's negative 4. So this is where a lot of students can make a simple mistake. I don't want you guys to make that mistake. Negative 4x. What's negative 4 times negative 1? Positive 4. So let's be careful when we do that. This equals 24. If I'm blocking your view, I'm going to keep walking. I'm going to try to keep doing this because I know if I stand over there, if I block you guys, if I stand over here, I think everyone can see it. So I'll probably try to remember to stay in this here. But let me know if I'm blocking you. Let me know. And you guys from here, of course, combine like terms, right? 3x minus 4x is just negative x. 6 plus 4 is 10 equals 24. So negative x plus 10 equals 24. I'm running out of room, so I'm going to bring it up the next line, next to the next slide. Negative x plus 10 equals 24. Next up, subtract 10, so negative x would equal 14. And divide or multiply by negative 1, so x would equal 14. One way you can think of negative is like saying the opposite of x is 14, so x is negative 14. Any questions about this problem where it gets confusing, where it was, if it was, where it was maybe scary at any point? Makes sense coming back to you. I know the summer, it feels like it's, oh yeah, coming back to you. It's fun. Cool. Yes?
So the first part, it turns into 2 terms. But you know how we both are in the parentheses? And then on the second part, they have their own. So it turns into 2 terms.
Again, this is one term, and this is another term. Is that what you're asking? I'm not sure if I'm answering your question.
But the second part is turning into their own.
The second line here?
Yeah. You know how in the first part, the 2 terms have their own.
Like they're in the same parentheses, and then afterwards they have their own parentheses in the inside term.
Yeah, I mean, I could technically do this. If that makes it more clear, like make these brackets. If that might make it more clear. Like this is this guy. So when we do this, it is so it's extremely important that there's 3. It's the entire value x plus 2. It's not just the x. So that's very important. Does that answer the question? Okay. It's always safer to use more parentheses than it is to use less too, by the way. I don't think we're going on, let's see. No, we're not doing a TAP schedule. We're doing a regular schedule, but we have the TAP meeting next period. Okay, so we still have the regular 9:20. All right, so that's that. Any other questions? All right, so that's solving a linear equation in a single variable that contains fractions. Let's see here. Okay, so now let's move on to solving a rational equation. We have something like x over x minus 3 is equal to 3 over x minus 3 plus 9. So notice we refer to this as a rational equation because we now have the variable component is like in the denominator, even if it's just in one of them. Okay?
Mr. Brooks,
Yes,
what's the thing on the end?
it's a 9 now. Very long tail. Okay, anyone have any ideas where you might want to start with this? Okay, so think about moving like make sure you have all your x's on just on one side. Okay? So you want to get rid of this guy? Is that what you're saying? Alright, so that's perfectly fine. Remember, you're allowed to do whatever you want to one side as long as you do it to the other side. Okay, so if we subtract, so minus 3 over x minus 3, subtract that from this side. It's a very sad looking 3. But it is a 3. So if we do that, I don't know if I write too big, but if we do that, we have x over x minus 3 minus 3 over x minus 3 equals 9. So you could do that. You want to have an idea of the next step? Yes.
I was just going to ask if you could just read
There we go. Yes. Good. Same mentality. Let's get rid of the fractions. To do that, we'll multiply the whole thing by the LCD. Now the LCD is going to be x minus 3 because the denominator of this guy is x minus 3, the denominator of this guy is x minus 3, and the denominator of this guy is 1, 9 over 1. So the LCD is x minus 3, so let's go ahead and we're going to do that. We're going to multiply, and I'm going to do this because I have a room over here. Can I write off the white? We'll still record that. Probably won't record that. So x minus 3. And this guy, of course, also multiplied by the same thing, x minus 3. I'm going to have to go to the next slide, so I'll wait till you guys got that part. Okay, so when we do this, what is this guy going to become when we multiply this whole value by x minus 3? You say x squared? If it helps, let me see, I'll give you a, and always think of it like this, that lets you see it. But there's an advantage to why we're doing what the young lady in the back said to do this.
Oh, just cancel it out.
Exactly. That's the convenient. Yeah, that's what we're going to do. So imagine, okay, that and that go away to 1 and 1. I want to, for you guys, I just want to emphasize the basic principle that's going on here is like if you have something like this, you know, the A's go to 1 and 1, leaving you C over B. That's kind of the big picture you're going to deal with when solving these rational equations with single variable. that's like the big idea. So for here, where would we end up now? We'd end up, the first guy would become just what? Just x, right? So x, I hate to jump back and forth, but that's what we're going to do. The next guy would become minus 3. It's going to equal this, which we could probably go ahead and distribute now, right? What would that be?
9x minus 27.
Thank you. 9x minus 27. Before we continue, there's something about this problem that we need to specify that's important. There's a certain restriction on x, because what's one thing in math that's a big no-no? That's like the black hole of mathematics. Division by division by 0. I think we had a lesson where divide by 0 is undefined. So therefore, what we should state from the very beginning is that x cannot equal what? I think x could be 0. I think x could be 0. Let's see. 0 divided by negative 3. That's a defined value. What's that? Yeah, x cannot be positive 3. Now we probably won't even run into this issue, but in case we happen to land on that solution x equals 3, know that in fact would be an extraneous solution because x cannot be 3, because we cannot have division by 0. Okay. What is that? Come on. Please put it away. So, can I have division by 0? This is such a simple thing that so many students will overlook, especially when the problems get more complicated and you do have extraneous solutions. And they'll say, oh, these are my solutions. But like, wait, one of them is not a solution. One's an extraneous solution because of the restriction. Okay? And even I did it. I skipped over it. So I encourage you to get into the habit. As soon as you're presented with an expression or an equation where division by 0 could be a possibility, state the restrictions on your variable. Okay? This probably will not be an issue, but it's important to note that x cannot be 3. Okay, so now we're here. All right. Anyone?
If the x is on the same side.
Yeah, the x is on the same side. Back to that general idea, all my x's, my variable on one side, and all my constants on the other. Okay, there's more than one way to solve these. It doesn't matter which way you want to do it. Whatever you guys, what do you think?
Or the x number.
All right, so you want to get rid of this x? Yeah, that sounds good to me. So minus x, in which case you would have just x's over here. And so if I want to just have constants over here, at the same time, I'm going to add 27 to both sides. You guys don't have to do this in the same step. I'm doing the same step. You don't have to. But you can. Because it's still balanced, right? I'm doing the same thing to both sides. Okay, that's the great thing about math. As long as you follow the rules, you may end up doing more than is necessary sometimes. And like, well, crud, I could have done it a lot easier. But if you obey the rules, you'll never be wrong. So, negative 3 plus 27 is 24. And that equals 8x. And then last but not least, divide both sides by 8. So x would equal, oh, x can't be 3. So wait a second. I thought they wouldn't trick us right initially, but in fact they did. So x cannot be 3.
So no solution.
Yep, the last paragraph. The proposed solution 3 is not a solution because the restriction that x cannot equal 3. There is no solution to this equation. So the solution set for this equation contains no elements. The solution set is the null or the empty set, which you guys may or may not remember this symbol. So uh-oh, can't have that. So this is the solution. It's a null set. There is no solution to this equation. I'm kind of glad that they gave this because it emphasizes to, you need to be careful with your restrictions. So there's absolutely this going on. So this cannot happen because we said it couldn't because it division by 0, so there is no solution. We'll do one more similar to these. Or do you guys want to move on to a different looking problem? What's that? Move on? Okay. Solving a rational equation to determine when two equations are equal. Okay. And you guys don't have a book, so I'm going to have to write it out. That's fine though. Or a lot of you don't have a book. So we have, this is page 109. We have y sub 1 equals 1 over x plus 4 plus 1 over x minus 4, and y sub 2 is equal to 22 over x squared minus 16. And the directions say find all values of x for which y sub 1 equals y sub 2. So I'll put that here. Find all values of x so that y sub 1 equals y sub 2. That's the direction. Okay. What's the first thing we should do? Before that. Beautiful. Because if you don't do it, I guarantee you'll forget to do it. What can x not be? It's a restriction to x cannot be 4 or negative 4. So it cannot be plus or minus 4. And that covers both equations, right? Yep. See if you guys remember, what is this situation called here? Special scenario? Special case? The name makes sense?
Difference between squares.
Difference of squares. Because that's exactly what it is. It's a difference of squares. Very good. All right. So next step, you said set them equal to one another. So find all values of x so that this is what's going on. Y sub 1 equals y sub 2. So let's go ahead and do that. So y sub 1 equals y sub 2. And y sub 1 was this. 1 over x plus 4 plus 1 over x minus 4. This needs to equal 22 over x squared minus 16. All right, raise your hand if you don't like fractions. I'm one of those people. Most people don't like fractions. So I'm always going to get rid of fractions each and every time I can. So keep that thinking process, just like the previous two problems. Let's get rid of fractions if we can. Why not? Yes?
Is there a way we can break up the 22 so that like it's like you can do the you know what? Never mind.
Okay.
We could have did it like two, but
Let's focus on getting rid of the fractions as quickly as we can because no one likes fractions.
it would be nice.
So x squared minus 16 is same as x plus 4 times x minus
Good.
Yeah.
You're exactly right. So if we factor this, it's going to give us some information that's going to help us. So this equals 22 over difference of, that's why difference of squares, it's something that you guys should definitely have memorized, and hopefully at this point recognize difference of squares like in your sleep, like that. Difference of squares, difference of cubes, sum of two cubes, Pythagorean theorem, quadratic formula. Okay.
Pick one and divide it.
What's that?
Pick one and divide it. It don't really matter.
Pick one and divide it out.
X plus 4 will give you X minus 4.
Oh, okay.
That's what I'm trying to say.
Well, what would we have to multiply the whole equation by so we get rid of all the fractions? Now, I don't want to be too lazy here. I'll write it. That's the same thing. I could do this too. This makes it, you know, that those are contained, those are a binomial in the denominator. So, what do you think? What can we multiply the whole equation by so we get rid of all these fractions?
It wouldn't be the difference of two squares. It wouldn't be the X.
It would be.
It would be X plus 4.
Because that would cover everything. Right? If you just multiply by, say, x plus 4, both sides by x plus 4, well, that would work out for this guy. You would just be left with 1. But here, you'd have x plus 4 over x minus 4.
So you might do it by both of them.
Yeah.
Multiply by X squared.
And, I mean, you could do that and then end up doing x minus 4, but why not just do it all at one time? Right? So let's go ahead and multiply both sides of the equation by the least common denominator, which is x plus 4, x minus 4. So I want you to know when you have linear factors, this is a linear factor, this is a linear factor, if they don't look the exact same, just include all of them to cover all of them. X plus 4, x minus 4. Not quite the way I want to write it because it looks like it's over it, but it's just like, should be just like that guy. Okay? So the same idea. Raise your hand if you have any questions about what's going on. The distribution. So what will we have now? Yes.
X minus 4 plus X plus 4.
Yeah, because for this guy, that each would go to way of 1, leaving you x minus 4 times 1. We have x minus 4. I'm going to put the times 1 just for a visual. Just because in case it's not 1, I want you to know that that's what's going on. Plus x plus 4, because when you distribute this whole guy to this term, the x minus 4s would go away to 1 and 1, leaving you x plus 4 times 1. And this would equal, this whole thing goes away to 1 and 1, leaving you just 22. And then from here, it should be pretty straightforward. Okay. Pretty much it for today. Any questions about anything? Keep in mind, tomorrow your syllabus sign off is due tomorrow. You can turn it in today if you want. Okay. You don't have one? Let me get some.